Hello everyone. In this video we're going to be solving a nice exponential equation. We have 3 to the power x multiplied by a to the power x over x plus 2 equals 6, and we're going to be looking for x values. I'll be presenting two methods, even though we can probably talk about more than two methods here. Let's go ahead and see how we can solve this problem. The first method is going to be kind of separating the powers. So I want to go ahead and write the 8 as 2 to the third power and then raise it to the power x over x plus 2 and write the 6 as 3 times 2. Obviously, I'm not going to just say, hey, 3 to the power x equals 3, so x equals 1, because that's not going to work. But I will put the powers of 3 on the same side and the powers of 2 on the other side. Let's do it and see where that takes us. First of all, we have the multiplication, so it's going to be 2 to the power 3x over x plus 2, and that is equal to 3 multiplied by 2. Great. Now, let's go ahead and bring the 3 over here so we can divide 3 to the x by 3, and we can divide, actually that's probably going to be easy if we do it the other way because this power is more complex. So let's go ahead and divide the left-hand side by 2 to the power 1, and divide the 3 by 3 to the power x. This can be handled easily. So now these are first powers, so we can go ahead and subtract the exponents. So 2 to the power 3x over x plus 2 minus 1 equals 3 to the power 1 minus x. All right, so let's go ahead and make a common denominator and subtract. That means subtracting x plus 2 from 3x. That's going to be 2x minus 2. Don't forget to negate the 2 there. And this is going to equal, and obviously we forgot to divide by x plus 2. And this is going to be 3 to the power 1 minus x. Awesome. We got to do a little bit of more work to see what is going on, because you could also say, hey, I can just guess and check. We'll do that later. But for the first method, it'll be a little easier. Because I'm going to, you probably notice, x equals 1 makes the left-hand side exponent 0. And the same thing is true for the right-hand side. So we can do the following. We can go ahead and write this as 2 to the power 2 times x minus 1 over x plus 2. And 3 can be actually flipped and write as 1 over 3, and then raise it to the power x minus 1. So the idea here is basically when you have a to the power negative n, you can write it as 1 over a to the power n. Or 1 over a to the power n, because 1 to the power n is always 1, so we can write it either way. That's the idea I used here. So now I'm going to go ahead and write it this way. 2 to the power 2 over x plus 2 to the power x minus 1 equals 1/3 to the power x minus 1. Obviously here the bases are different, even though there's a variable inside. Here's what we can do. First of all, notice that we have x minus 1 on both sides. So that kind of tells us when you have something like a to the n equals b to the n, and if a and b are different, then, and if they're not 1 or negative 1, then the only option left for you is n equals 0. Because if a and b are different from 0, and obviously 1 and negative 1 are also some exceptions, but we can safely say that a to the 0 equals b to the power 0, because they're both equal to 1. Make sense? So from here, it's not guess and check. You can see it clearly, hopefully. X equals 1 works. Great. So that's one of the solutions. Nice. Another solution is going to come from the fact that after assuming that x does not equal 1, so we're going to raise both sides to the power 1 over x minus 1. So we'll get rid of x minus 1 and then just set this base equal to the other base, because we're done with the first case. Now the second case gives us the following, and from here we can basically solve by ln'ing both sides. Let's go ahead and do it. And you could also use log base 2 if you want, but I'm going to use natural log to be consistent with these things. And then we get the following. And then from here we can basically move the power to the front, right? That's a really nice property of exponents, I mean logs. That is 2 over x plus 2 times ln 2 equals ln 1/3. I mean, if you want, you can write the 1/3 as 3 to the power negative 1, divide by ln2, so on and so forth. There's a couple things you can do, but let's go ahead and just keep it as is and divide both sides by ln2. And then we're going to flip both sides because that makes finding the x a little easier. And that's going to give us the reciprocals on both sides. You can also put the 2 in parentheses, doesn't really matter, no big deal. And then we're just going to multiply both sides by 2. It's going to give us 2 ln2 over ln 1/3. And then we can subtract 2 from both sides and we should be done. And obviously, if you want, you can go ahead and make a common denominator and kind of write it in a different way. But that is going to be the other solution. And along with x equals 1, we have 2 solutions to this equation. All right? So great. So let's go ahead and take a look at the second method. And that's going to be a little different approach. And I'm going to show you the graph of this function at the end. So it has a really interesting graph. All right, cool. So what do we have? We have 3 to the power x multiplied by 8 to the power x over x plus 2 equals 6. For my first method, I separated the 3's and the 2's and put them on separate sides, took care of the x minus 1, and then we looked at 2 cases. Here, we're just going to natural log both sides, just ln, because a lot of times this method works fine, right? So let's go ahead and do it, even though this is going to require some simplifying. It is going to work. So now we have a product, and product ln of a product can be written as sum of 2 ln's, like this. And then we can use the power property. And the power property basically tells us that, hey, we can move these to the front. Let's do it. That's going to give us x ln 3 plus x over x plus 2 times ln 8 equals ln 6. Awesome. So now we have an interesting equation with x's and ln's and so on and so forth, and our goal is to solve for x. Let's go ahead and do the following. First of all, get rid of the fractions. Multiply both sides by x plus 2. If you do that, multiply the whole thing by x plus 2, then you're going to get x times x plus 2 times ln 3 plus x plus 2 is going to cancel out, x times ln 8 equals x plus 2 times ln 6. Awesome. And what do you see? X times x gives you x squared. And yes, this is going to be a quadratic equation. Great. So let's go ahead and distribute x squared plus 2x multiplied by ln 3. And actually, I can replace ln 8 with ln 2 to the 3rd power. And I can replace ln 6 with ln 3 times 2. And then we can go ahead and obviously move this power to the front and split this into a sum. So let's go ahead and do it. After that, we're going to rearrange the terms and write this as a full quadratic. So this gives us 3x ln 2. And here we get x plus 2 multiplied by ln 3. And then also by ln 2. All right? Because we are able to write this as ln 3 plus ln 2 and then use the distributive property. Great, so let's go ahead and put the x squared terms together. This is going to give us ln 3 multiplied by x squared. And then we're going to get 2x times ln 3. So what we can do next is basically put this all together. So, but let's go ahead and distribute first. I think it'll be easier if we subtract everything. So here we're going to get x plus 2 times ln 3 minus x plus 2 times ln 2, and the whole thing is going to be 0. Okay, so let's go ahead and see what we get from here. I have 2x ln 3 minus x ln 3 minus x ln 2 and 3x ln 2 minus x ln 2. So here's what we're going to get. ln 3 multiplied by x squared. Let's look at the coefficient of x. We got 2 ln 3 minus ln 3. So that's going to be ln 3. Makes sense? And then we're going to have 3x ln 2 minus x ln 2. That is going to be 2x ln 2. So 2 ln 2. And both of these are going to be the coefficient of x. So we're taking care of x basically. Now we're going to look at the constants. The constants are going to come from here. We're going to get minus 2 ln 3 minus 2 ln 2. By the way, you could also write this as minus 2 ln 6, which is probably going to be a little easier. So we're going to keep it as a single term. So we didn't have to split up here actually. Just leave it like that and you'll be fine. And this is equal to 0. Great. Now we got a beautiful quadratic. How do we solve this? Let's go ahead and use the quadratic formula. But let's go ahead and find the discriminant first because I want to simplify it. Discriminant is this guy over here squared minus 4ac. And then that's going to negate and 2 ln 6. And I think at this point I'll probably want to split them up again. Okay, it's kind of like back and forth because everything is in terms of ln 3 and ln 2. When we square this, we get ln 3 squared plus 4 ln 2 squared plus 4 times ln 3 times ln 2 plus when we distribute this, we get 8 ln 3 squared. Notice that they're both ln 3, and this one is going to give us plus, and by the way, don't forget this is always 8 because 4 times 2, it's going to be 8 times ln 3 times ln 2. Awesome. Let's go ahead and simplify this and make it awesomer. ln 3 squared plus, now we have ln 3 squared plus 8 ln 3 squared, so that's going to give me 9 ln 3 squared. So we've taken care of these two. And then I got 4 ln 2 squared. Good. But then I have 4 ln 3 ln 2 and 8 ln 3 ln 2. Those are like terms, so when I add them, that's going to be 12 times ln 3 times ln 2. And guess what? This is a perfect square. Yay! How is it? 3 ln 3 plus 2 ln 2 quantity squared is going to give us this. Because if you think about it, call this A and call this B, you'll get the idea. So since that's the discriminant, we can go ahead and plug it in here. Oh man, where's the formula? Okay, x equals negative b. So we got to go back to our quadratic and find out where b value is. Where's my full quadratic? Okay, let me go ahead and mark it for you. This is our full quadratic, and this is our a. But we do need negative b, so that's going to be negative 2 ln 3 minus 2 ln 2. That's actually, this is 1 ln 3, not 2. So it's going to be negative ln 3 minus 2 ln 2. Negative b plus minus the square root of delta. So the square root of delta is going to come from here. That's going to be 3 ln 3 plus 2 ln 2. And then that's going to be divided by 2a, which is 2 ln 3. Awesome. Now I'm going to go ahead and, forgive me for this, but I'm going to go ahead and make some room here. I'm going to erase some stuff. And then what we're going to do is we're going to simplify the roots and write them in the simplest form. All right. Great. Now here's what we have. This is our quadratic. The first one of the roots, is going to be negative ln 3 minus 2 ln 2. Let's use the plus sign. Plus 3 ln 3 plus 2 ln 2. What's nice about it is that 2 ln 2 cancels out. We get 2 ln 3 over 2 ln 3. By the way, this is ln 3, not ln 2. I messed up on that one. So this is going to be 1. Yay, we already knew that. Come on, x equals 1 is an obvious solution, right? Okay, let's look at the other one. The other one is going to come from the minus sign, negative ln 3 minus 2 ln 2 minus 3 ln 3 minus 2 ln 2 divided by 2 ln 3. And that is going to be minus 4 ln 3 minus 4 ln 2 divided by 2 ln 3. And if you take out a negative 4, you'll get ln 3 plus ln 2 divided by 2 ln 3. 2 goes into 4 twice. This is going to give you negative 2 ln 6 over ln 3 as our second solution. If you go back to the first method, you notice that this is eventually going to turn into something like that. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment. Oh, I was going to show you the graph. Come on, we're not done yet. Okay, this brings us to the end of the video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.